Welcome to Breeze Physics. Today we're just going to solve a problem right from Reddit dealing with centripetal motion, period of rotation, etc. We're going to use the guess method in order to solve this, which just says write down your givens, your unknowns, your equations, substitute and solve. Let's do it. A space station has a radius of 100 meters. That's a given. Radius equals 100 meters. What is the period of rotation needed to provide artificial gravity of g at the rim? All right, so they told us that g is our acceleration. I don't know what you use in your class. We're going to use 9.8 meters per second squared right now. I'm not going to worry about significant figures right now. I'm just going to solve stuff. You do significant figures that you need to do for your specific class. The question says, what is the period of rotation? Now, as part of the guess method, what we do is we just go and find an equation that we can solve. In order to solve it, there can only be one unknown. It turns out this student has this equation right here. Do we know acceleration? Yes. Do we know the number 4? Yes. Do we know pi? Yes. Do we know the radius? Yes. Do we know the period? No. So it's the only thing we don't know, and we can solve it. So now we write down AC is equal to 4 pi r over t squared. All we have to do now is substitute and solve. I'm going to rearrange first, and I'm going to say t squared is equal to 4 pi r over AC. So t is equal to radical 4 pi r over AC. That AC is under the radical. T is equal to radical 4 pi times 100 meters divided by 9.8 meters per second squared. You put that all in your calculator and you find out that T is equal to something like 20.07 seconds. Done. First one's over. All right, next question. At what speed is the rim moving? Again, you go to your reference table. Right now the question is, what is the speed that the rim is moving at? There's more than one way to do this. You might find that the speed is equal to the distance over the time, or you might find that AC is equal to v squared over r. I prefer this equation for this setup. So, do we know AC? Yes. Do we know v squared? No. Do we know r? Yes. Again, we have one unknown. This is the power of the guess method. You just look for an equation where there's only one known and you solve. If you do this in physics constantly, you will just keep getting answers. So we are solving for v this time. So we're going to rearrange to say v squared is equal to AC times r, and v is equal to radical AC times r. V is equal to radical 9.8 meters per second squared times 100 meters. We plug that in a calculator and we find that our velocity is, our speed is 31.3 meters per second. That is our velocity at a given point, but we're constantly changing direction. Boom, done. Number 2. That was a breeze. Okay, so the next question is, what is your apparent weight if you run opposite the direction of rotation? Opposite direction of rotation means you are going to be decreasing your speed. So let's erase this. And we're going opposite. So our speed is going to be minus 4.2 meters per second. So our speed is actually only going to be 27.1 meters per second. And apparent weight is the normal force on us. Since we're going in a circle, the normal force is the centripetal force pushing us towards the center of that circle. Again, we just go to our reference table. We find an equation. Do I have mass? Yes. Why do I have mass? My assumption here is that the student forgot to give us mass based on the way the question is asked, since they didn't ask relative to your force on Earth. So we have mass. Yes, I made up a mass of 70 kilograms. Velocity. Do we have velocity? Or rather, do we have speed? Yes, we have speed. Do we have r? Do we have the radius? Yes, we do. So it's a simple plug and chug. FC is equal to 70 kilograms times 27.1 meters per second. Do not forget to square this. Divided by 100 meters. FC is going to equal, I just plugged this in, 514 newtons. Again, I don't know in your class what you do for sig fig, so if you get a number around there, you're probably correct. Let's erase this. Let us look at the next question. The next question says, what about when you run in the same direction? So when you run in the same direction, you're going to go around the circle faster. All you did is you increased your speed, and so instead of subtracting that 4.2, you will add that 4.2, and you are now going 35.5 meters per second. Again, it's a simple plug and chug. FC is equal to 70 kilograms times 35.5 meters per second. Do not forget the squared. You will be very unhappy. Divided by 100 meters. We plug it in, and we get 882 newtons. Boom. A breeze. Super simple. We use the guess method. We don't even have to understand the physics. In which direction would you run to get the best workout, with or against the rotation? Or does it matter? If you want the best workout, you want it to be feeling like you're extra heavy. So you want the increased force on you. And so in this scenario, the answer to the question is actually going to be running in the same direction, because you're going to feel heavier. So your muscles are going to get more of a workout. That's it. That was a breeze. Check out my other videos. Check out my website, www.breezephysics.com. Contact me at steve@breezephysics.com if you have any questions. Maybe I can make a video that can help you too.